Welcome to the SWAN North American Alliance Skill Briefing hosted by Frost and Sullivan. Today's event is titled Boosting Adoption of Smart Water Networks Through Policy. My name is Ana Guerrero and I oversee Frost and Sullivan's Skill webcast program. Before we begin our event today, I'd like to go over a few quick notes. This presentation will be available immediately on demand, and you can view it at the conclusion of the webcast. We encourage you to ask questions throughout the presentation, and you can do that by clicking on the Ask a Question button. You can also safely share this webcast at any time by clicking on the Share button within the player. On today's presentation, we will have some detailed slides, so there's a full screen feature available to you at the bottom right-hand corner of the screen. Our presenters today are Jeff Lape, Deputy Director, U.S. EAPA, Tim Braun, Enterprise Architect, EmNet LLC, Peter Mulvaney, Senior Manager, West Monroe Partners, and Chris Resendez, Founder and Managing Director at Iot Impact Labs. Also, I would invite our audience members to click on the Attachments tab to find out a little bit more about the SWAN North American Alliance. The Alliance is free to join in the U.S. and it is a utility-driven and we produce tangible results. So click on that link during the presentation and you'll find out some more details about the Smart Water Network Forum. With that, I would now like to hand the presentation over to Seth.
Great. Thank you very much, Ana. My name is Seth Cutler. I'm a Senior Industry Analyst here with Frost & Sullivan, but primarily my role here today is part of the SWAN North American Alliance. I help to arrange and organize events like this webinar that we're here today. So it's really my pleasure to have you here all on the line. And like Ana said, there is that hyperlink there to go to the SWAN Forum, the North American Alliance, just to learn a little bit more about it, to understand if that's something you would like to join. We can certainly help you to better understand what its goals are, why you would want to join. You can get an example of who the partners are. But really the goal of the Alliance is to help accelerate smart water and wastewater development in North America through collective global industry expertise. SWAN is a broader global organization, so it's a great place for different stakeholders to come together and exchange experience. But this alliance in particular covers the US and Canada, so we're looking at engaging a lot of key industry players and utilities, regulators as well. As a centralized source for information, we have had a past workshop in January in San Diego that went very well. We had about 200 attendees join. So we're looking to continue our engagement with a broader audience around North America through this webinar. I'll just quickly do a brief introduction to the speakers here before I set up today's agenda. So quickly, Jeff Lape, who's the Deputy Director for the U.S. EPA, he's really devoted his entire career to the protection and restoration of water resources and the environment at a watershed scale, local, state, and federal levels of government and in the private sector. He's held senior leadership positions throughout the EPA for 25 years. He is currently the Deputy Director of the Office of Science and Technology in the Office of Water. Among other roles, he's the Chief Water Technology and Innovation Evangelist. Jeff has a bachelor's in environmental science from SUNY Plattsburgh and a master's in environmental science and engineering from Virginia Tech. Next, we have Tim Braun, who's an enterprise architect with EmNet. Tim received his bachelor's degree in economics from Bluffton University and his MBA in sustainable business from Presidio Graduate School in San Francisco in 2009. After a career in sustainable investment management, Tim became a clean tech entrepreneur and venture capitalist, focusing on water and renewable energy technologies. Tim joined EmNet in 2013 to expand the company's reach and impact by building partnerships with municipal utilities and their consultants. Tim leads the company's strategic vision for growth and client relationship development. Third, we have Peter Mulvaney, who is a senior manager with West Monroe Partners in the energy and utility practice. Pete is focused on serving the water management industries from source water protection through consumption and reclamation. He comes with over 20 years of providing strategic water resource management across the globe, working on projects of all scales and components. As a consultant, Peter has led the utilities towards smart cities initiatives and developed resilience and climate change plans. He obtained an MBA from the Kellogg School of Management, a Master's of Science in Environmental Pollution Control from Penn State, and he's received a Bachelor of Arts in Psychology from the University of Colorado. Last, we have Chris Resendez. He is the founder and managing director at Iot Impact Labs. He is helping to translate the potential of the Internet of Things, of machine-to-machine and other enabling technologies into meaningful, profitable, sustainable means of differentiated value creation. Iot Impact Labs is a commercialization accelerator. They focus on bringing IoT to small and mid-sized businesses, operating in grand challenge markets such as agriculture and food, water, energy, cities, and more. Chris is a graduate from Harvard University. To look at today's agenda, I've just gone through a little bit of the introduction, but next what we want to look at is Jeff Lape, and he can talk about the role of water information and new monitoring technologies to improve U.S. water infrastructure. Then it'll be handed off to Tim Braun, who will talk about blue infrastructure, smart water solutions for CSO cities. Next, it'll go to Peter Mulvaney to talk about unifying fragmented watersheds. And last, we'll talk with Chris Resendez about opportunities in community resilience from Central Valley, California to Pine Ridge, South Dakota, and through South Coast, Massachusetts. Quick note on Chris's slides, there's a bit of an IT issue, so he'll mainly be doing an oral presentation, but there will be a couple of slides that will help him carry through the talk. At this moment, I'd like to pass it over to Jeff Lape, who can talk a little bit more. And here we go. Jeff, please take it away.
Great. Seth, thank you very much. It's exciting to be joining you about a conversation about how water information is on the cusp of a major transformation, I believe, and going to impact how we manage our water resources going forward. We all remember what Peter Drucker said, you can't manage what you don't measure, and I think I'm going to sort of give you my punchline right out of the box. Our past information systems have served us pretty well in the water world, but we are on the cusp of new sensor and sensing technology along with information technology that I think is going to basically give us real-time, continuous information on water, and that's going to transform just about everything we know about water. That's quantity, quality, use, and that's not only surface water, but also groundwater and the managed water that we have. I'll also make reference to an exciting report that was just issued by the Aspen Institute about sharing and integrating water information. And that, I think, is just going to be a wonderful complement to this new technology. So folks are seeing it left and right. We're seeing new technology like sensors that are providing faster, more data, real time, of known quality, where there's much more metadata associated with it, and it's more accessible. And that's accessible because, in part, people are willing to share that data, and we have the technology to manage it. Just as an example, this graph is just intended to help juxtapose the nature of water data. You'll see the red dots might represent traditional grab samples or even composite samples, in this case for two different parameters. I'm not expecting you to read it, partly because I can't read it either, and I'm just going to have to remember, I think, that these plots are for dissolved oxygen and nitrate nitrogen. The point is not precisely what the data shows, but just the robust nature that when you overlay continuous monitoring data with traditional grab sample data, you see a fundamentally different picture of what that information is showing, and you begin to juxtapose, in this case, potential impacts of nitrate nitrogen might have on dissolved oxygen. So we've recognized the opportunity of sensors and their potential here at EPA, and I just simply wanted to put a plug in for some of the federal agency work that's underway. Denise Shaw with our Office of Research and Development has really been the champion for a nutrient sensor challenge, where we basically laid out specifications for nutrient sensors, for example, that they could exist in the environment for 6 months unattended and achieve known data quality. And that whole event took place. Winners were announced, and we had the wonderful joy of seeing some of these sensors actually installed and providing real-time data. The Bureau of Reclamation has been doing an arsenic sensor challenge, and our Region 1, Region 2, and ORD folks have also advanced a septic system nitrogen sensor challenge that could help us understand the performance of on-site septic systems. I also want to just put in a plug for some early work that EPA is doing. This is being led by Dwayne Young here at EPA to actually mine the data on a watershed scale, both static and continuous data, and put it together. We've done this in a couple of pilot watersheds. I've provided you with the access on the slide to the demo tool. You can actually go in real time and see information. And this also captures about 15,000 sensors that USGS has deployed at the current time. So I encourage you, for folks who want to begin to see the possibility of accessing this data. We imagine that this is something that could be replicated perhaps in time in every watershed that's attempting to do water resources management. So I mentioned briefly this exciting Aspen report. The Aspen Institute, along with the Nicholas School at Duke and Redstone Strategy, pulled together 40 people and said, boy, how do we make the sharing and integrating of water data a realistic approach? I must admit, I've got to go forward and see. Oh, I thought I had one more slide, but no. So I'm going to go back. In essence, this report was just released in May last month. It provides a great business case for sharing and integrating water information. It lays out a national policy framework for data standards, data sharing, and what I think for any utilities, municipal utilities that might be patching in today, Appendix 2 actually provides some explicit examples of how local utilities can play a key role in sharing information and data. And I'll just give you an example of where that is happening. Here in Washington, the utility is DC Water, and they have a website where you can go to any property in the entire district and see online the extent to which there is a lead service connection, either the public side or the private side, for every single property in the District of Columbia. And for us, that's a great example of making data and information available in a way that folks can see and work with it. So that was sort of the context, Seth. I get that one of the key questions we want to try to propose is, how do we align our policy framework to actually improve the availability of smart water information? And I guess our short answer would be EPA sees this as a great opportunity because of technology and would encourage folks to network using, whether it's our integrated interoperable watershed framework or other frameworks, to actually put this data together and make great decisions. So with that, I'll quit and turn it over to my good partner, Tim.
Hi, Jeff. Thanks. Seth, just FYI, I think I figured this technology out in the last 10 seconds, so we're good to go.
Great.
Let's see if I can actually advance the slide here. There we go. All right, we're in business. Hey, so thank you very much for inviting me to talk a little bit about our work with City of Evansville, Indiana, and Evansville Water and Sewer Utility. Just a quick bit on EmNet. EmNet is a water technology company based in South Bend, Indiana. We've been building real-time decision support systems for starting in South Bend, but now working in over 20 cities across the United States. Basically, the work that we do is to understand, control, and dynamically optimize urban watersheds, collection systems, wastewater networks on a real-time basis. So what's interesting about Evansville is, like South Bend, is another small to medium-sized Rust Belt city in the Midwest that's using, in our opinion, pretty cutting-edge technology to address their combined sewer overflow problem. So a little bit of background on Evansville. If you think I was always brought up to think of Indiana as being the shape of the foot. So if so, Evansville's down in the big toe of Indiana, located right on the Ohio River, serving a population of about 140,000 people. For a city that size, approaching 2 billion gallons of CSO annually is a pretty substantive problem. And thus, $730 million long-term control plan to address those problems is pretty arduous for the city to take on. But I'll jump right in here. One of the first things we do when we're working with a client is to first turn on the lights with distributed sensor networks and then user interfaces that can actually be populated in real time to see what's going on hydraulically throughout the collection system, as well as go back and replay events from the day before, the week before, the year before on a forensic basis and learn how these systems actually work. And we think this is actually pretty pivotal because for a lot of clients, this is the first time they're actually seeing the real world hydraulic behavior of their collection systems. What's also cool about this part of the approach and the work is that we can use data analytics to show where they're getting, from an operations and maintenance standpoint, to show where they're getting silt, grit deposition in the collection system and how it's what needs to be addressed most urgently. But I think what's really cool about what Evansville is doing, what you're looking at here is the Pigeon Creek Interceptor, which starts over on the right and goes downstream into a 7th Avenue lift station, where it's then pumped into a force main and then goes by gravity to the treatment plant, which is at the bottom of that V on the very left-hand side of the page. These big circles that kind of look like, Imperial starfighters are actually CSO gates that either allow flow to go into the interceptor or overflow into the Ohio River or into Pigeon Creek. And so what we developed with the city is an automated control program that actually controls the behavior of those CSO gates and then provides a decision support dashboard for the operators at 7th Avenue lift station to tune the pumping volume at that lift station to meet the future capacity 45 minutes later that we expect to have at the treatment plant. Again, we're doing this through a distributed sensor network combined with automated controls in real-time decision support dashboard. And so what the operator is looking at here is both a numerical as well as a visual representation of the data that include of all the critical data points that would support the decision that's being recommended in the top center panel. So it's very much like a GPS on your phone, for example. You take the recommendation based on the situational awareness, or you neglect the recommendation and the system continues to provide recommendations on what to do next. So what's I think also interesting about this is historically the operators would actually have to drive around and when the system was surcharged, like you saw on that previous screen, the operators would actually have to drive around in a truck and open those gates one by one to relieve the system so it didn't overflow into the streets and basements and so forth. And now it's all done on an automated basis. And the guys operating this can actually sit back and watch it from the plant in a supervisory control mode. In fact, they're so confident in this decision support dashboard now that they're actually saying it's time to automate the lift station as well. So what about results? So this approach is relieving or reducing CSO volume by about 100 million gallons a year. The good news with Evansville, and something also interesting about this particular case study, is that all of that equipment, all of that infrastructure already existed. We just needed to do a few tweaks, upgrades to SCADA, remove some head restrictions, and voila, 100 million gallons of CSO reduction for less than a penny a gallon. And their next least expensive project was actually 17 cents a gallon. And their composite cost for all of the various projects in the long-term control plan is about 31 cents a gallon. So we're looking at about 2 orders of magnitude improved cost effectiveness or cost efficiency from this approach. So I think with that, I think there's going to be time for questions at the end. I want to go ahead and hand it off to Pete.
Thank you, Tim. And I'm going to pick up on this theme here of how the Internet of Things, collaboration, and good governance can help to unify fragmented watersheds. And quickly, in my 10 minutes here, what I'd like to cover is, first off, just demonstrating the impact that poor water management can have on our urban environments. Highlight how data can be a unifying force for a watershed, and then demonstrate that collaboration is really gaining traction, as some of the earlier speakers mentioned. So first off, hopefully we're all aware of issues such as Toledo, which sits on the edge of the Great Lakes, 20% of the Earth's fresh water, and yet they had a water quality problem as a result of a failure in their watershed that resulted in turning off the water for the city of Toledo for several days. And I'm sure we're all aware that Lake Powell's been at historic low water levels, an indication that drought is creating more competition for water. And here's an image of Houston after a rainfall, clearly a problem within the watershed. And ultimately here, what we're talking about is how the fragmentation of our watershed limits our ability to solve these problems. But luckily, there are some encouraging trends. What I'd like to highlight here is the first trend on the left is how watersheds, the utilities are serving more water-conscious customers. We're all becoming more aware of these issues, and it's becoming more and more clear that these need to be solved in order to improve our society. Also, these watershed advocates are shifting from sort of environmental fringe elements to becoming real stakeholders with a valued voice in the management of water. And utilities are building capacity to manage data, to collect and manage and analyze data. And finally, there's a trend of regionalization where utilities across the country are becoming more focused on regional solutions. And all of these trends are important because society expects solutions to our water quality, scarcity, and flooding. And none of those problems can be solved alone. They all require a great deal of collaboration because an individual utility or stakeholder lacks the scale of influence. They lack the appropriate or full picture of the data, and there are gaps in the science that need to be solved with collaboration. And that's what we see happening is this formation of both data and governance collaboration, which will help enhance operations, improve regulations, and decision making. This slide here demonstrates how our watershed is actually broken into different components, from source to use to reclamation and back to source. And what I want to highlight simply is that the regulations we have from a federal basis divide this system, right? At the sink, between the sink and the drain, is where our federal regulation divides between water as the Safe Drinking Water Act and sanitation with the Clean Water Act. And if you dig down deeper, you'll all know that this fragmentation begins really with our education as we become trained in specific components of the watershed. And here what I'd like to do is just highlight from a slide from the Skidmore, Owings and Merrill, which has highlighted the watershed basin of the Great Lakes and St. Lawrence River. And as we overlay the various jurisdictions, we can see that there's over 15,000 different cities and towns among the other jurisdictional divisions of this watershed, including over 3,000 water utilities. Now, from a watershed management perspective, this fragmentation makes it extremely difficult to have a holistic perspective. And then again, drilling down to the city scale, here in Chicago, you can see across the top of this table, we have the various components of our watershed, the way we've divided it, from source through use and reclamation. And on the y-axis, you can see the different agencies. Highlighted in orange are the legal authority that each agency has in these different components. Again, highlighting how the management of our watersheds are extremely fragmented. And what we see happening here, as some of the other speakers alluded to, is this convergence of the Internet of Things with IT infrastructure, i.e. the cloud, and big data analytics. And this convergence is going to allow a more holistic understanding of our watersheds, which will ultimately inform the way we plan, improve our innovation, and ultimately transform the way we govern water. Looking at this image one more time, where we've got our different systems, and what we envision is that each of these systems is embedded with sensors. Could be like the EmNet system on the collection system. And this information is all shared in the cloud under analytics, so that that information is shared equally amongst the various components of the watershed, so that our folks in the reclamation side of the business understand the information that the folks in the water, the purification side, are looking at. And that this information becomes more available to the users on the consumption side. And it's not until we can all see the full arc of the watershed that we can really, truly make the best decisions. And in sum here, I just want to highlight a few of the key takeaways. First off, watersheds are being fragmented. I think that's very clear. And second, I believe that utilities need to step up and become the hub of this information. They're the ones who are building this capacity and ultimately will be responsible for the management of our watershed. And what can they do? They can provide and collect this data and make it available. They can develop the platforms necessary to collect and share the information. So ultimately, the IoT, such as advanced metering infrastructure and cloud-based analytics, will offer new ways to bring our watersheds together. In my last slide, I just want to highlight two examples that I encourage folks to look at offline after this webinar. One is the Southern Ontario Water Consortium, which is up in Canada, where they've actually done just as we're talking about here today. They've implemented sensors throughout a watershed. They have a consortium of utilities and universities and technologies that are working to solve problems at the watershed scale. And then the other example, which I think is really terrific, which is the California Data Collaborative. And as you can see from the image here, their splash page, they're advocating data as the future of water management. And I encourage people to take a look at both these sites to learn a little bit more how utilities and others and stakeholders are really working together to solve some of these problems. And with that, I'd like to pass it off to Chris.
Peter, thank you so much. Jeff and Tim and Peter, you guys have done amazing work, and you've articulated and shared the stories brilliantly, and you're to be commended for your ability to both do the work and share it. And so now, as the last speaker, I'll try not to be the slow kid in the room. First, I'll apologize for saying that the exhibits that we had delivered were just simply too heavy. I had not done optimization to the slides or the maps or the GIFs, and so the reason why I don't have exhibits for you folks right now is that we just didn't manage the data well. But what I'd like to do is share some stories that have arrived us at a conclusion that is almost near perfectly aligned with what these gentlemen shared with you. What our team has done is taken what we've learned from these gentlemen and from their partners, and we've tried to go to what we call the austere edge of water security. And in order to do that, we figured we needed to start in a place that had high density competition for ideas, for intelligence, digital intelligence, and for capital. And so we did a project in 12 contiguous vineyards on 80 acres in California and tried to get to a place where we could, in fact, have conversations with growers who are ultimately the nearly 80% consumers of the fresh, potable groundwater, sweet water that exists, at least in North America, if not on the planet. And see if we couldn't communicate with them to get them to understand that these new digital tools would not, in fact, displace them or their experience and not, in fact, put them at risk, but it would help them better manage risk. So what we did was started with groundwater, sweet water, in some cases surface water, the natural asset, and see if we couldn't get the folks who were in the position to own or control or be stewards of that water to be owners, controllers, and stewards of data about that water. And we were successful building a small network of growers in California to invest in groundwater monitoring solutions that were commercially available off the shelf, and also to accept a set of terms and conditions under which that data would be protected and private, but at a different resolution or a different level of detail be shared with their peers, and then yet at another level of detail or resolution be something that we'd call a commodity or a commercial market available digital asset. Our success in California led us to start asking our questions about, well, who else might we be able to pilot with to prove these points? And so we chose what is probably a pretty unlikely community, a middle market community in southern New England that had been experiencing drought conditions more than flood conditions, had been experiencing some water quality conditions, and was a hybrid system where as many as 5,000 properties in a town of 35,000 people, where half the town was served through a municipal water system and another half of the town was served by private water wells and private cisterns, we might be able to instrument there too for presence, level, and quality of water. And the results were similar. If we could position these new tools to be complementary and not necessarily disruptive in an unintentional way, then we could gain the trust of residential, agricultural, commercial, light industrial, and also municipal stakeholders to see that these tools wouldn't necessarily be threats, but that they would in fact be risk management tools, that they could become economic tools, and that ultimately they could become resilience tools. And so that middle market success got us to thinking about where else we could go. And so after being invited by the Tribal Investment Board representation among the Black Hills Tribal Council, we went out to Standing Rock and we went out to Pine Ridge. And for those of you that don't know, Pine Ridge is generally considered to be one of the most at-risk counties in North America. Some would say a bottom 10 county based on the traditional methods of population health and education and economic attainment. And there too, we were able to position IoT, or sensing and instrumentation, digitization, data, analytics, all these tools to not necessarily be threats to tradition and culture, but to be conceived of and accepted as a tool, even for sacred water protectors whose names are not shared and whose work is through secret societies, and where that data can never have a commercial implication. With the tools and technologies available to us, we're able to literally create multiple identities on a single sensor. So a single sensor in a single field, on a single well, a single tank, a single cistern, can create multiple exfil or extraction of data so that while the sacred water protectors can be assigned one of those extractions or exfil to achieve their culturally sensitive and traditionally important roles, we could also create data feeds or extractions that could be used for all the purposes that Jeff and Tim and Peter described earlier. And so our story is a fairly simple one. We took much of what these gentlemen have been working on independently, in parallel, with some common second or third parties, and we went and tested these ideas, not in bigger cities with larger universities, and certainly not with what you'd consider to be the typical elite in technology or environment or economics, but we took them to the everyday ordinary people in middle markets in Massachusetts, and we took them to folks that might be considered on the edge, indigenous communities. And what we found was that everything that these men are describing is not only real and happening today, but it's a requirement that virtually every community we've been touching accepts and is eager to lean into. Our vision of the future aligns with what these gentlemen described. We are going to have to create new ways of being, new ways of working and consuming and producing based on changes in climate and water availability and quality. We're going to have to do that by getting ground truth, better data, better intelligence, getting smarter. And much of that is going to come from having a higher density footprint of sensing and instrumentation points of presence, not just in cities, but in austere environments as well. And ultimately, our ability to better manage these critical resources, including and especially what we think is the second most precious resource on the planet, water, second only to oxygen, we know that we're going to have new opportunities to create economic value. So we're trying to build these new business models that would enable and accelerate against what we call resilience. So these new businesses in commissioning or in data management or in financing the development of new infrastructure or the redevelopment of existing infrastructure could be branded and could be truly delivered as resilient, as being secure, stable, scalable, agile, profitable, sustainable, and equitable. And I'm sorry that we don't have more pictures for you, but there are literally dozens of commercially available sensing and instrumentation technologies that are technically stable, operationally relevant, and financially affordable for all of these communities. They're available today. These companies are doing business with us and with our partners, and I'm sure with Jeff and Tim and Peter and their partners. And we're excited to be part of this conversation. We're excited to be part of this water security future. And I would encourage you to please reach out to us at iotimpactlabs.com. If there's anything we can do to contribute or be a contributor independently or with Jeff and Tim and Peter and others, we're proud to be here, happy to share a little bit of our stories. And with that, I'll turn it back to Seth.
Wonderful. Thank you very much, Chris. I mean, these presentations are really pretty great. What I'd like to do now is just to open up the floor for some Q&A, if there are any questions from people out there listening to this presentation. I know we do have a couple in that are in already, but just to inform everyone, at the top of the screen there is an Ask a Question button. You can relay your questions through there for all of us here on the webinar. Just to start things off, I know I just had a little bit more from Tim. I know we discussed earlier just what you're doing in Evansville. Could you maybe give us a few comments on that, Tim?
Sure. So the work that I presented is the work we've been doing over the last several years on the west side. The city's kind of split into east side and west side with two different treatment plants. The next sort of scope of work that we're working on is maximizing the utilization of a wetland treatment facility that will in turn reduce the number of activations for their high rate treatment facility from 17 activations down to 11, which reduces the amount of flow treated from 126 million gallons down to 38 million gallons in a typical year. What all that translates to is the collection system will now, again, through basically giving a software upgrade to the sewer system and the treatment assets, it'll enable the city to handle significantly larger events and coordinating control of these assets, as well as they have a number of storage tanks in the downtown area. So that's what's next. So again, similar kind of results from getting higher and better utilization out of the assets they already have.
Perfect. So for another question as well, just for the team here, the importance of resilience was mentioned. Do you think it's important for water utilities to develop a long-term water resilience strategy? And if so, why?
This is Pete Mulvaney. I'll take a first crack at that. I believe it's absolutely important for utilities to have a resiliency plan. There are a number of reasons. One, the process will highlight some of the risks that the utility faces, and it may expose them to different ideas, different types of solutions. But also because their customers, largely industrial, commercial type customers, are going to be asking them in the future, in the very near future, if not today, what their plan is for resiliency. Because companies want to know the risk exposure that they have to water shortages. So if you're a company that relies on water, which is just about everyone, they will be asking utilities, what is the resiliency plan? What are the backup plans? What is their plan to make sure that their business will be able to have a consistent supply of water? A resiliency plan is a good way to articulate that, what the utilities are doing to protect their customers. I'll pass it to my other speakers.
This is Tim. I'll answer quickly. And so I think just about every client we're working with is facing, whether it's a coastal client, they're facing sea level rise and saltwater intrusion into their infrastructure. We have lots of clients who are having 100, 500, 1,000-year storms every few years. So they have no choice but to develop a resiliency plan and prepare for larger and more intensive events than they've had in the past. And so one of the good news bullets about this overall approach that we've all been discussing here is not only are we getting higher capacity utilization out of existing assets, but actually we're understanding the system as a system and balancing flows throughout these watersheds in a way that actually reduces surcharging and buildup of flows at bottlenecks. And so it actually can extend the life of the infrastructure while it's getting a higher capacity utilization.
This is Chris. I'll jump in and say that we think it's absolutely critical for a number of reasons, echoing what the previous speakers just said. But what I'll add is that what we're seeing in our work, whether it is an instrumentation-led upgrade of a brownfield or existing infrastructure facility or site or capability, or if it's a new greenfield, what we'll call hybrid infrastructure development with a much higher degree of instrumentation and connectivity and remote, real-time, pervasive, persistent digital views, we're seeing more private capital and we're seeing more private management and operation. And the capital markets are demanding for these types of projects, at a minimum, much higher pedigree and attestable risk management and risk reduction. And they talk about definition or redefinition, assignment, reassignment, pricing, repricing, mitigation, or elimination of risk. And in many ways, that's the beginning of a conversation around resilience. So while I had a 7-dimension definition of resilience, what we'd argue is if you titrate it down to risk and risk management and the appropriate identification and pricing of risk, we think it's critical that the smallest to the largest, the urban and the rural, the brownfield and the greenfield, have resilience strategies or have, by definition, change their views of what their roles are in their communities by making resilience core to their conception of their roles. And we would argue that in a future where we think more of the infrastructure will be privately funded or financed than privately managed or operated, it'll be an absolute entrance fee to the game.
Great.
Seth, it's Jeff. So I'll just simply also acknowledge that resiliency is an important part of the risk portfolio. But I also imagine that the future of smart watershed networks are going to open up opportunities for collaborative problem solving at a watershed scale that we've yet to fully wrap our heads around. I think there are going to be great opportunities for enhanced ecosystem protection, water reuse, water sharing, and only the robust sharing of water data at a small scale is really going to open up those possibilities.
Perfect. The next question for the panel. We spoke about regional challenges and available data-driven solutions. Do you find cities are sharing their management experience with other cities sort of at that level or even outside of the U.S.?
This is Tim. I can take a shot at that. Yes, I think what we found to be really interesting in the market is some of the most advanced utility leaders A, they think they're the only one, and B, they're a little nervous about sharing what they're up to for fear of, I don't know, being seen as maverick or renegade, and or maybe getting some unwanted pressure or what have you from a regulatory body. But we've been encouraging more and more collaboration between cities, particularly ones who are on kind of on the cutting edge and willing to take on new and interesting technologies. And I know, then there are some classic utilities like DC Water, for example. George Hawkins has been they actually have programmatic systems in place for interacting with other utilities and others as well. But I'll let my colleagues answer as well.
This is Pete. I'll just say that I agree with what was just said, that especially that utilities are a little resistant or hesitant to share. Sometimes it's because they're not quite sure how, or as they enter this process of sharing information, they do it piecemeal as opposed to the whole system, resulting in sort of this hodgepodge of access. And so there are some technical challenges, I think, that come along with this collaboration. It's oftentimes a desire, but not necessarily the technical know-how to do it.
Great. All right. I think probably our last question for the briefing here. Is it viable to phase in the capital investment costs of IoT and cloud or hybrid infrastructure for utilities or cities that wish to venture down this path? Alternatively, is it highly recommended to commit instead to large-scale projects to achieve the same goals?
This is Tim. I think I can speak to this. So we think that the approach that we've taken is one that is demonstrated. Evansville is just one example. We've got quite a list of examples where the return on investment, maybe not 100x or approaching 100x like we've seen in Evansville, but still 5, 10, 20x improvement in cost effectiveness over sort of traditional approaches to either combined sewage or separated sewer system surcharge or overflows and whatnot. So I think it's both and, though. I don't think, for a lot of the cities we're working with, you can't get all the way to the design criteria, the consent decree or long-term control plan just on, IoT and big data analytics alone. Some can, but I think the majority of cities are still going to need some gray infrastructure, green infrastructure, et cetera. And so, but I think one of the advantages of this approach, and something I didn't discuss at all that we've been working on, is actually using machine learning to dramatically improve the hydraulic and hydrological model to the extent that A, it can be run in real time, and B, it's so accurate relative to the real world it can actually be used as a control tool. What it also allows us to do, and other firms like Optimatics, who we partner with from time to time, doing this as well. You're not just optimizing the existing infrastructure, actually creating an optimal future set of CIP projects that can be built and controlled with the same approach. So we definitely encourage this to become part of the overall investment budget, but yeah, I think I'll leave it there.
This is Pete. I'd like to take that conversation upstream a little bit. That was a great explanation from the drain side. As we think about this on the source water side, I would say that we cannot solve the source water problem simply by building more large capital programs to increase our storage capacity. It needs to be coupled with demand side management on the consumption end. And that's really done best with more information, with this integration of, as we've been talking about, the IoT, cloud, and analytics, and information sharing. So just the flip side of that discussion is I think that I don't believe that big capital projects alone will be able to get us to where we want to be from a supply side story.
This is Chris. I'll add in that our experience on the ground is that while there is lots of excitement around shovel-ready and or big shovel requiring capital projects with big budgets and long schedules and these long tails of employment opportunities and related, we think that there will be a combination of financial structuring to arrive us at a broad range of project scope and scale. But where we think it needs to begin is at the source, at the same time that we're doing the larger capital projects in cities, where a lot of this material and resources and energy is being expended or decisions are being made. So we believe parallel paths with projects that are both large and small, but we would argue that the key has got to be ground truth on the baseline location, state, and status of the water itself that we're looking to be exploiting as resiliently or as intentionally as possible. And that with this thing called IoT, when you do have an appropriate instrumentation of a physical asset, natural or machined, or inventories, areas of operation, processes, and teams, when you can get that data that is secure and is operationally relevant, and you can put it into networks of existing digital assets and networks of existing subject matter experts and networks of existing operators, as well as enabling the creation of new processes, we believe that that's where you have the opportunity to accelerate and scale at margin, where you have the opportunity for folks to see that these new solutions are not necessarily going to be cost centers, and that the new methods and processes and models that are emerging will in fact deliver the returns that the previous speakers spoke about, whether it was Tim or Peter, Jeff, and others, but that truly entirely new approaches to sectors of society or sectors of the economy are going to be enabled. And what is going to be required is not just a digital mentality, but a synthesized mentality of these traditional infrastructure projects, these traditional operations being perhaps disrupted intentionally rather than just disrupted by having this data. And the economics associated with the capitalization of the project or the financing of the project through OpEx is going to be one of the heady debates of the next, we think, 5 to 10 years. What we think is going to happen is that we're going to see smaller projects, more highly distributed, more privately funded, and they're going to be really creative methodologies to create revenue from the intelligence that comes out of not just the sourcing systems or the reclamation systems, but at every point in between, because that data is going to be a new asset class that's going to be incredibly powerful, and our understanding of how it can be exploited in a financial, operational, or conservation context, we think will change the traditional discussion of large or small, public or private.
Wonderful. Thank you, Chris, and thank the rest of the panel as well for answering those questions. I think really we're going to wrap it up today, and this really concludes today's presentation. I hope everyone's found the webcast informative. Again, I would like to encourage everyone to use the attachments tab to find the SWAN North American Alliance link, where you can find out more information about the Alliance itself. You can understand more what we're doing, how to register and become a member as well, which is currently free. So it's really to use this webinar as an example of a lot of the information, a lot of the good quality insights that we're generating through the great contributions we have here on the line. So I would encourage everyone to look more at the Alliance, to join and to participate, and to help really the exchange of information on how we can push the adoption and understanding of data-driven solutions within the water industry. So do feel free to contact us if you have any questions, if there's additional feedback. This webinar will be archived. It will be put onto the North American Alliance website. You can also find it through the Frost & Sullivan archive as well. So if you do want to highlight this for colleagues or other people you know that would be interested in this content, really do feel free to do that and to pass it around and make sure we can amplify these messages so that everyone can really gain a little bit in their jobs and their roles. So thank you, everyone. I look forward to future webinars. We'll certainly have newsletters going out from the Alliance that will help inform you to our activities. So do also sign up for that newsletter. But just to leave it there, I'd like to thank Jeff, Tim, Peter, and Chris, and we'll all be in touch with future events. Thank you very much. Bye-bye.